quality control means. So my today's topic is on, actually, just a minute, design of experiments. Design of experiments. And in this, if I go by the syllabus, in the syllabus it is mentioned, the first design of experiment that has been mentioned is called full factorial design or 2K design. So, but I shall not start that 2K design or full factorial design right now, because first of all you have to understand what design of experiment is. Okay, and for this I must first of all want to discuss about analysis of variance. Analysis of variance, it is also a kind of design of experiment where some factors are given, and on the basis of the factors some means are calculated, and you are to test that whether these means are aligned with one another or not. Okay, this is very vague, which I have told you right now, because actually the study of this design of experiment asks from your end some sort of preliminary knowledge on testing of hypothesis. So design of experiment actually requires the knowledge of testing of hypothesis. Testing of hypothesis. So since it requires the knowledge of testing of hypothesis, so first of all, let me very briefly tell you about what testing of hypothesis is. If you have studied BTech course in engineering, so FT, so probably there you have seen, probably so far as I can remember, you have encountered testing of hypothesis in the statistical course. Have you encountered statistical hypothesis testing in your BTech course? Have you ever heard of this particular term, Vijita and Moushami?
না স্যার, আমি হাইপোথিসিসটা করেছি বলে মনে পড়ছে না।
টেস্ট and what about এটা কে, Vijita না Moushami, কে বললে?
হ্যাঁ, মৌসুমী।
Okay, and Vijita, what about Vijita?
Actually স্যার মনে পড়ছে না, 2009 পাস আউট আমি বিটেকে।
Oh, okay.
ভুলে
Now,
গেছি।
okay, so let's talk about hypothesis testing a little bit, because if you are not comfortable with hypothesis testing, you will not be able to understand what design of experiment is. Now, what is hypothesis? I'm going to talk about how to test a hypothesis. Hypothesis means it's a statistical equivalent to the word assumption. That is called hypothesis, to the word assumption. Okay, so as we literally said always that we assume something. Okay, so we assume that system, we assume that thing. In statistics we also assume, and that assumption is actually called hypothesis. Okay, so these two words are equivalent to one another. Now question is what to assume, and on whom this assumption is to be made. That is a very important question. What to assume, and on which and on whom this assumption is to be made. Okay, so as you have come across the two terms called population and sample, you are familiar with this term. And in statistical quality control also, I have several times mentioned these terms successively, population and sample. And in statistics, population and sample actually plays a very important role. So you know the population is a large set which contains the sample, and we select the sample on the basis of some criteria or some methodologies are there by which the samples are chosen. Why do we select sample? Because we want to study sample, and on the basis of the result obtained from the study of the sample, we want to declare the something about the population. Say for example, if suppose I'm assuming that 50% of the food technology students are interested in doing maths. Suppose this is my assumption, okay, but question is from where I am actually getting this assumption. uh, this is a very important question. This term, this particular number which I have mentioned here, 50%, this number has not been obtained from uh, studying the population, because food technology is studied in various universities all over the India, and if we count the universities all over the world, then this 50% is actually related to all the universities of the world who teach food technology. Okay, but it's not possible for me to go everywhere and ask students whether they are interested really in maths or not, and they are comfortable in doing maths or not. If they are comfortable in doing maths, then they are interested. If they are not comfortable, then they are not interested. So if I do so, it is not possible for me to go to every university and ask students whether they are comfortable or not. And if for the instance, for some time, if I assume that okay, it's possible, if it's possible for me to go to each and every university who have this particular program, food technology, in their universities, and ask each and every student, if I get this chance, then I'm not sure whether students will tell the truth. Okay, they suppose when the university will learn that someone is coming from outside to do some experiment or kind of thing, because whenever we do statistical experiment, I have to be very clear, and I have to uh, tell the subjects that I'm coming here to do some sort of experiment, and this is my motive. Okay, so this is called the statistical ethics. So if I say this, then probably the students will be told to give positive feedback. Okay, and we often do so. Even if we don't like something, we give positive feedback. So it may so happen that many students are saying, yes sir, I actually I'm interested in maths, doing maths, but probably he knows not interested, or probably he doesn't even know that he's not interested. So many things can happen. So it is no way true that if I write that yeah, 100% of the food technology students are interested in doing maths, it is no way true. So to be on safe side, I'm writing 50% of the food technology students. If 50% of students are interested, if 50% of the students are interested, then the students percentage of students who are not interested is also 50%. Okay, and since I'm a very positive person, so I'm playing a 50-50 chance over here in both the cases. Okay, so I am putting the equal amount of weights on each side and saying that yeah, this is a balance. 50% is comfortable and 50% is not comfortable. But the important thing is that this value 50% is a hypothetical value, okay, and this value has been obtained from the population. So in from the population, I am making a hypothesis. That is my hypothesis. And this hypothesis, where I'm claiming that 50% student is interested in maths. Okay, I am not considering the hypothesis on the basis of the sample. Sample has not come into the picture yet. This hypothesis, this positive hypothesis, which I have actually considered over here, this hypothesis is called null hypothesis. Null hypothesis. Null hypothesis means, the definition of null hypothesis is hypothesis of no difference. It is called hypothesis of no difference. I am not going into the details of that because I'm not teaching you hypothesis testing right now. But you have to know that actually we are to assume some sort of hypothesis over here. So null hypothesis is hypothesis of no difference, and the hypothesis I'm making on the population of students of food technology considered from all over the world, which I have not visited personally. I am claiming that 50% of the students is interested in doing maths. That is my null hypothesis. And null hypothesis is denoted by, null hypothesis is actually denoted by the term H0. Okay, actually why it is 0? 0 stands for basic. Okay, because you know that in classical system there are two things. One is called switch on and another is called switch off. Okay, so in switch on can be denoted by 0, switch off can be denoted by 1, or vice versa. Anyways, so I am declaring this hypothesis as my basic hypothesis, so I am considered here 0. Or if you can say that 0 is coming from, as I am saying, there is no difference. The difference, hypothesis of no difference. So difference is 0. So that's why the 0 has been put over here. So anyways, this is a notation. So if you are saying that 50% of the students is not interested in mathematics, so its alternative hypothesis will be, the 50% of students are not interested in mathematics. So alternative hypothesis is actually the complementary to null hypothesis. Complementary to null hypothesis. Complementary to null hypothesis. Okay, and alternative hypothesis is denoted by H1. So once we form our null hypothesis and alternative hypothesis, remember, whenever we study a system, we have to declare null hypothesis and alternative hypothesis, both of them together, because they are twins. Okay, so you cannot just write the null hypothesis and leave alternative hypothesis aside. You have to consider both of them together. And then comes the sample. After this, after designing my hypothesis, what we do, we actually select a sample. We actually select a sample from the population. Now the question is, from where do we select the sample? Okay, so we select the sample. We select the sample from the places which are accessible to me. Okay, so, or accessible to us. So for example, this means, and this means that suppose we are staying in Kolkata. So we are interested in knowing that how many students are actually interested in maths, how many food technology students are actually interested in maths. So first of all, what we'll do, we will try to get to know that in which universities or institutes of Kolkata this food technology program is available. So in Technomain Salt Lake, this food technology program is available, and in Jadavpur University this food technology program is available. So my first job is to fix on these two universities, and I'll be determined that I'm going to send the experimenters who are working under me to these universities, Techno India universities, and university and colleges, and Jadavpur University, and from there we are going to survey the students. Okay, because these are accessible, these are within my approach. Then if I want, if I have this money power, and if I have manpower, if I have time, if I have fund, then I can send my surveyors to some other universities which are outside West Bengal and have food technology programs over there. Okay, but if the fund is short, okay, and it will not be possible for me to send the surveyors outside India, okay, because it actually takes too much costs. Okay, and probably though no universities will be uh, interested in bearing that cost, so I cannot consider those universities which are actually outside India, uh, uh, so that I can select samples from there. Okay, I cannot consider them because of the costs involved. Also, suppose the fund of the research is so low, so poor, that even I cannot send my surveyors to West India or South India. I can at least reach to North India. Okay, so in this way, I have to select those universities from where I can get in touch with the students of the food technology department. So therefore, I have written here that those are accessible to us. That is very important. And the next important part is that once we select our uh, samples, I mean, once we select our domains from where the samples will be selected, say for example domain 1 D1, maybe suppose it is Techno India University, okay, TIU, and domain D2 is Jadavpur University, JU. And in this way I have selected suppose 10 domains, okay, 10 universities have been selected. Then comes how to select the students. Shall I select the students arbitrarily, or shall I go and ask each and every student? Okay, so for this I have to approach the authority of the department, say for example departmental head, or the placement, who the person who is responsible for placement of the students, and I have to approach them and tell them that yeah, I have come for this particular purpose, so give me some students so that I can actually survey him. Most of the time what happens that when people go to survey, then the subjects actually shut door on the face of the surveyor. Okay, so we are not interested in being surveyed always. Most of the people do so. So once I get this nodding, then the departmental head or the placement officer, they decide, yeah, okay, so this person has come and he wants to survey our students, so let's select some students. And what he does, he selects some attentive students or regular students from the batch, not the students who are backbenchers and not irregular. Okay, because otherwise they think that either they will give negative feedback, or probably that survey will be total mess, or maybe it will create a bad impression on the surveyor. Okay, I shall carry a bad impression with me after surveying those elements. So they select students who are regular, attentive, and who can be and maybe who those students who can be manipulated. So he gives me, suppose he gives me students like from 60 students are there in total in TIU, say for example. So he is giving me 40, and he is giving me from Jadavpur I am getting 50 students, and in this way here from here I am getting say 10 students, and so on. Okay, now suppose the survey is too I mean tedious, so my questionnaire is too long, so I have to question those students. Then what we do, actually we don't survey all the 40, 50 and these 10 students. What I can do is that I know that these students, 40 students, 50 students have been selected by the authorities. Okay, but I don't want to, I want to implement some sort of arbitrariness into the experiment. So what I'll do, I shall go for a lottery system, and I can ask all the 40 students, say in TIU, I can ask all the 40 students to be present in the class, and I will put a serial number to all the 40 students. They will write their names on the slip, and I can put all the 40 slips in a basket and shuffle it. And from there, I can select from this random sampling or shuffling, I can select, say, 20 arbitrarily for questioning. From there, I am selecting 20 arbitrarily for questioning. And since this is low, this number is 10, I can select 5 from questioning for questioning. So in this way, I can select my samples, and at last, these people will be asked some sort of questionnaire, which will be designed before I start doing the experiment. Okay, so this pre-designed questionnaire. And some sort of statistical tools are applied after questioning all the students. After the questioning, we use some sort of statistical tools, Statistical tool means some sort of statistical formulas. Okay, and we get some result. Okay, and suppose the result is denoted by R. R stands for result. My null hypothesis is what? 50% of the students, my hypothesis was 50% of the students are interested. Okay, and in every statistical hypothesis, there is a checking criteria available. There is no universal checking criteria for problem to problem, from system to system. This checking criteria is actually varying. So we shall try to apply this checking criteria on R, and if R satisfies the checking criteria, then we say that our null hypothesis is accepted. Or if R does not satisfy our checking criteria, we say that R is rejected. Sorry, H0 is rejected. Null hypothesis is rejected. H0 is rejected. Okay, so in this manner, in this way, we do the hypothesis testing. Now, if you ask me that what is that checking criteria, I must say that, yeah, this checking criteria is predefined. It is a kind of formula which you have to, you will try to correlate with your result R. Okay, there are some ways by which that can be done. All these things are actually taught in statistical hypothesis or testing of hypothesis, which I think is there in the, I have taught statistical hypothesis in BTech Food Technology in 4th semester, which goes by the code BSM 401. And since you are saying that you are 2009 pass out, in 2009 BSM 401 code was not there, and I cannot remember in which particular semester this statistical hypothesis was there in the previous code of food technology of BTech. If you have not learned, then you have missed, and this design of experiments will be kind of I mean, you'll be facing some sort of difficulties in understanding design of experiment, but I shall try my level best, because whoever set the syllabus, they actually think that, yeah, this prerequisite is well known to the students, so they know it, and therefore we can easily implement into the design of experiment. Or if whatever prerequisite is required for design of experiment, students can fill up the gaps by self-studying. Okay, so the syllabus set are things like that. So this is all about, very briefly, and like storytelling, I have told you what is hypothesis testing and how this can be done. Okay. Now my basic objective is to teach you about analysis of variance. Now I'm going into the details of that, because two factorial experiment and etc., these are all special cases. These come later. Factorial design comes later. Before that, we have to know about a linear model, which can be I mean, which is the first step towards design of experiment. Okay, so the model which I'm going to tell you about is called the analysis of variance, or in short it is called ANOVA. ANOVA. And this model is a linear model, and this model is actually defined as the model. The ANOVA model is defined as Yij is equal to mu plus tau. This word, this particular letter is called tau. Tau I plus epsilon ij. This word is called epsilon. This letter is known as epsilon. Epsilon ij, where I is equal to 1 to up to a, and j is equal to 1 to up to n. Okay, this is the linear model, and sometimes in place of mu plus tau I, we write mu I, and we write mu I plus epsilon ij. Okay, and mu I is actually called mean of ith treatment. It is called mean of ith treatment. Now don't be, don't get nervous, because I have used this notation over here. Also, I must say that capital Yij is the random variable. It is a random variable denoting I comma j th observation. Random variable denoting I comma jth observation. So don't get nervous by looking into this mathematical terminologies. These mathematical terminologies will be simplified when we shall get into the detail, and I'll give you tools by which we can solve problems. Okay, you don't have to study much, because even if I tell you to study, then probably you will not, or probably you are not comfortable in this particular thing, and because of lack of time also. So I shall try to optimize the thing and tell you this much, and you have to study it well, so that you can do the problems at least. So analysis of variance is a kind of thing which is called ANOVA, and its a linear model is defined in the following manner, where mu plus tau I is sometimes called mu I. Okay, and it is the mean of ith treatment. Epsilon ij is called the error term. It is the error which can creep in into the experiment. So you have to know this basic mathematical formula for the model. Okay, now forget it. Don't have to worry about it much. Till at this point, till up to now, if you have any doubts regarding the basic of this testing of hypothesis, that you have not understood this page number 1 and page number 2, you can ask me. Otherwise, I'm carrying on. And if you have any question regarding hypothesis testing H0 and H1, then you can stop me and ask me questions. Okay. Anyways, let's start about the experiment. Suppose we have small a number of treatments. suppose treatments, and we have observations which are denoted by y11, y12, y1n, y21, y22, y2n, ya1, ya2, yan. Okay, these are the observations, and we want to study this with respect to ANOVA, and this ANOVA is the model which I am going to study here. ANOVA has various types. The type which I am going to describe is called single factor type. It is called single factor analysis. Okay, so I'm going to talk about how to study single factor analysis where treatments are given as this and observations are given as that. Now you can ask me that what is this treatment and what are these observations? Okay, now I am going to set one example so that you can easily understand what I am talking about. For example, try to imagine that I am talking about an agricultural field, and I have this agricultural field be divided into several blocks like this, and this agricultural field is actually producing a particular item, a particular vegetable, say for example. Okay, this example I am setting from pedagogical point of view, so that you can easily understand, you can correlate with the practical system. I am actually considering an agricultural field which has been divided in several subfields like this, as I am drawing right now. Okay, and I am making these blocks also over here, as you can see, and each of these subfields, the value y11, y12, these are actually giving you the production of the vegetable I am talking about. So yij, which is written in small letters, you can say that capital Yij, which has been written over here in this particular model, is talk about production. It is the mother variable, production of vegetable, and this capital Yij has several values which are denoted by small letter Yij. Say for example, capital Yij we have y11, which gives you the production of that vegetable in the field, in the cell 11. In this cell, the what is the production? In this cell, what is the production? That is your y11. In this cell, what is the production? That is your cell, that is your value y11, y12, like this. So all these values y11, y12, these are the special values for the mother variable that is called production of variables, production of vegetables. And how many variables are there? And the last one is yan. Okay, so all these are productions of each individual blocks. Now suppose you see that I have divided the first, if I consider this particular part only. Okay, so let's put a different color over here. If I consider this block of the field, in this block of the field, which have several sub blocks, like 1 is a sub block, 1 2 is a sub block, 1n is a sub block, all these have been considered under the same block, and there I have applied the treatment 1. Treatment means some sort of fertilizers have been used. Fertilizer 1, say fertilizer 1 have been used over here. Fertilizer treatment means fertilizer 1 have been used over here in this sub block. Okay, fertilizer 2 have been used. Fertilizer 2 have been used in this block. fertilizer A have been used in that block. Fertilizer A have been used in this block. Okay, so several fertilizers. How many fertilizers are there? Small a number of fertilizers are there. Fertilizers. How many fertilizers are there? Small a fertilizers are there. And I want to check, we want to check whether the production of the fields remains same after, even after using these fertilizers, even after using these fertilizers. Okay, so I want to check this. Fertilizers. Okay, so that these fertilizers are actually the treatments, the tau I, which they are talking about in general. So in place of tau I, you can say that we have tau 1, fertilizer 1, tau 2, fertilizer 2, and in this way we have tau A, fertilizer A. Okay, so if I am using these fertilizers, will be fertilizer A in this particular sub block, will the production of that block will increase or not? So how many treatments are there? Single treatment is there. Single type of one type of fertilizer is used. Only one type of fertilizer has been used, and therefore that analysis is called a single factor analysis. My time is running out for the session 1. In the session 2, I'm going to continue on that, because if I continue right now, automatically this session will be terminated because of this time frame. So in the next session, we are going to continue.
স্যার একটু বাকি আছে স্যার।